Hello everyone, welcome to my channel Mysterious Mathematics once again. In this video, we are going to discuss a problem which appeared in the 2014 University of Connecticut Calculus Test. So what does the problem says? Let Fn be the nth term of the Fibonacci sequence, that is f1 is equals to f2 is equals to 1, and Fn is defined recursively for n greater than or equals to 3 by Fn is equals to Fn minus 2 plus Fn minus 1. Now obviously this is the standard definition of the Fibonacci sequence. It's a known fact which in this case we don't have to prove, that the limit as n goes to infinity Fn plus 1 upon Fn is equals to 1 plus root 5 upon 2. We need to show that the series summation as n goes from 1 to infinity Fn upon 2 to the power n is convergent, and we have to compute its sum. Now, to show whether a series converges or not, we need to carry out certain tests. For example, ratio test, root test, limit comparison test, direct comparison test, and many more. Now, just by looking at the problem, can you find out what test in this case do we have to carry out? Yes, I think you have guessed it right. It is the ratio test. It's quite easy to figure out why. Now, what is ratio test? Ratio test, simply let an be a sequence. Also, let the limit as n tends to infinity modulus or the absolute value of an plus 1 upon an be equals to L. Now we have three cases. Case 1, if L is greater than equals to 0 and less than 1, then the summation an converges. And by summation an, what do I exactly mean by summation an? Is that n varies from a finite non-negative integer to infinity. In this case, obviously, we have to show that n will vary from 1 to infinity. And case 2, if L is bigger than 1, then the summation an diverges. But if L is equals to 1, then nothing can be concluded. Through ratio test as well as through root test. Root test also has a similar kind of observations. If L is equals to 1, nothing can be concluded, then we have to try other tests. Okay. In this case, clearly you can see an will be Fn upon 2 to the power n. That is the series whose limiting value we have to find out. And L, you can clearly compute L, which is the limit as n goes to infinity mod an plus 1 upon an. That is will be simply 1 plus root 5 upon 4. And that is less than 1 because root 5 is less than 3. And if you add 1 to both sides, 1 plus root 5 will be less than 4. And then if I divide both sides by 4, 1 plus root 5 upon 4 will be less than 1. Okay. So, we can see that L is less than 1. So, and obviously clearly 1 plus root 5 upon 4 is bigger than or equals to 0. So, clearly our given series, that summation Fn upon 2 to the power n as n goes from 1 to infinity converges. So it will have a finite limit. So our next task, next work is to find the value to which the series converges. Okay. So how to find the sum? Now let the summation as n goes from 1 to infinite Fn upon 2 to the power n is s, be s. And obviously we can assign a finite value to the sum now that we know the series converges. Or we can rearrange s, we can write s is equals to f1 upon 2 plus f2 upon 2 square plus the summation as n goes from 3 to infinity Fn upon 2 to the power n. And why have we done such a thing? Because the recursive relation that the Fibonacci sequence follows, which is Fn equals to Fn minus 1 plus Fn minus 2, that's only valid for n bigger than or equals to 3. So what have we done? We have separated the first two terms and then we have written the same series from 3 to infinity. And in the next step, we know f1 and f2 both are 1, so we add them. That will be 3 by 4. So that s equals to 3 by 4 plus the summation fn minus 1 plus fn minus 2 upon 2 to the power n. What have we done? We have simply used the recursive relation of the Fibonacci sequence. In the next step, we have isolated again. So 3 by 4 remains 3 by 4. And what have we done? We have taken fn minus 1 upon 2 to the power n, and we have isolated a half. We have extracted out a half from that. So that becomes half into summation fn minus 1 upon 2 to the power n minus 1. And similarly, the second term also. So that becomes plus 1 by 4 into summation fn minus 2 upon 2 to the power n minus 2. Limit remains the same from 3 to infinity. Now, the next step, that's crucial, but it's also not that hard. So s equals to 3 by 4 remains 3 by 4 as usual, plus half into, now the first series, that is summation fn minus 1 upon 2 to the n minus 1 from 3 to infinity. That will be s minus half, and the summation as fn goes from 3 to infinite, fn minus 2 upon 2 to the n minus 2, that will be simply s. Why is that? That's a very easy thing. You can post it in the comment section if you want. And then simplify both sides and you will get s equals to 2. So we have found out our converging value for the series. So the summation as n goes from 1 to infinite, fn upon 2 to the power n will be simply 2. So it converges, and it converges to 2. So if you like the video, please hit the like button, subscribe to my channel for more videos to support the channel and for getting notifications of those videos. And if you get benefit by the video, please like, share and subscribe. Thank you. In the next video, I'll be back with another interesting problem.